of 2025. I am so excited to be here today with Ferras Hamad. Hey Ferras, what's up, man?
Hey, what's going on, Hugo? Great to be here.
I'm so excited to jump into talking about infrastructure applications, how infrastructure and data science and ML can actually deliver business value, particularly in building systems and not just models. Really excited to talk with you, especially with your breadth of experience being a machine learning leader at DoorDash, formerly at Netflix, Meta, Uber. And I didn't know this, but before that, your first job, where you started doing AI/ML stuff at Yahoo as well, working on personalization there.
Yeah, I did the full Bay Area tour. Got like my punch card. Just maybe like a couple more left in me.
Fantastic. I'd like to welcome everyone who's joining live. Welcome to Out of Bounds Fireside Chat, the our first one for 2025. Please introduce yourself in the chat. Let us know where you're watching from, what your interest is. Do you work in data science, ML, AI? And what are you up to? A bit about Out of Bounds. Out of Bounds builds open source software and products that help you build both ML and AI applications, including LLMs. Out of Bounds works on infrastructure and productivity tools that allow data scientists and MLEs to focus on building models and systems and doing science while having easy access to infrastructural layers such as compute, orchestration, versioning. Doing a lot of that through the open source Metaflow, but please check out of Bounds platform as well. And I'll link to the GitHub for Metaflow in the chat. And it isn't always that I get to do this. But I'd love to hear your thoughts on Metaflow for us. And maybe you can tell us what Metaflow is useful for, having worked on it and worked with Ville, of course, at Netflix as well.
Yeah, I mean, full disclosure, I did work on Metaflow at Netflix, and was part of the team that helped open source it. So my view may be a little bit biased, but it is one of the best software products that I have used. It's I guess from the outside looking in, it's deceptively simple, right? But the amount of things that it handles really makes the MLE's life a lot easier. Uh, and it really hits that sweet spot in terms of abstracting at the right layer,
Mm,
right? So it's opinionated where it needs to be, but where probably MLEs have care the most about, it really gives them free reign, right? So
absolutely.
that's really the distinguishing factor that I really see with
Yeah.
Metaflow. It's built in such a way that it's easily integratable into a variety of different stacks, right? And even if there isn't an open source support for, whatever you're depending on internally, it's pretty straightforward to build your own custom plugin. But more likely than not, you actually find somebody has already built that plugin for you. So, I'm a big fan of it.
Yeah. Awesome. And in terms of the abstraction layer it provides, I do agree. One example I like to give is the at Kubernetes decorator. And this is one of many, but as I'm a scientist, man. I'm not a software engineer or infrastructure engineer. So the fact that once I have a cluster provision for me, I can just slap on that decorator, specify the memory, whatever I need, if I need GPUs or whatever, and attach that to a step, and it does the
Works.
work. It's sending it up there and bring the results back, right?
Yeah, it works and it's reproducible, right? So if you
Important for
run
software.
something, yeah, if you run something once, it will run in a different environment and others could run it as well, right?
Mm, yeah,
So that's a huge thing. A lot of software engineers take reproducibility for granted, but that's one area, from the ML side that is lacking at a lot of companies and hasn't become as standard practice as it should be.
totally, totally. Well, let's jump in, man. And to your point, I think a lot of the standard practices that have developed in like more tech forward, like serious tech companies, like the ones you've worked at. Part of the work now is to get all of those behaviors and systems and let people know what's happening, right? Which is one reason I'm super excited about chatting publicly with you about this, because you've worked at Netflix, as I said, Meta, Uber, DoorDash, and Yahoo. So I'm wondering, like, what drives your passion for machine learning, and how have these experiences in their different ways shaped what you do and your approach?
Yeah. I mean, what got me interested in ML is the same thing that got me interested in computer science, like more broadly. ML is a space that's applicable to almost anything. Really provides the opportunity to pursue both depth and breadth, right? If you want to go deep in a specific area, you could go like for decades, right?
Mm,
If you want to, right? But then there's also just so much breadth to it as well, right? Different areas of ML, AI, everything from knowledge graphs to LLMs to whatever. And then, the ambiguity that comes along with really productionizing ML systems really gives you the opportunity to express your creativity, right? So like how you model the problem, what proxies can you use to get like ground truth data, what are you optimizing for, just all these different aspects, is really what drives my passion for it.
amazing. Um,
Yeah.
and I suppose before moving into kind of how ML can deliver value to all of these different types of companies, I'm wondering at a place like DoorDash, why is ML infrastructure so critical, and what impact does the infrastructure have on business outcomes?
Yeah. So if you look at DoorDash, really the breadth and variety of problems that require ML or want to leverage ML, right? You have store recommendations, we have tools that are used by merchants, improving search, our product knowledge graph. There's some interesting blog posts related to that. If you guys want to check out the
Mm,
DoorDash blog, just a quick plug there. Even like core infra, right, has use cases that want to leverage ML, right? So you have the diversity of problems, and we're also very early, right, in our life cycle. And we're looking for step function growth or leaps even in the business, right? And that requires a lot of innovation. And infra is really what drives innovation, right? If you want to really make an impact in these almost greenfield areas, you need to have infra that's set up to well support that, right? To be able to quickly jump in a new area, try out different things. And that's one of the reasons why ML infra specifically at DoorDash is so critical to the business and ensuring successful business outcomes.
mm, fantastic. And I've linked to the engineering blog for DoorDash, so people can definitely check it out. I am interested. We live in a world where LLMs reign supreme in the cultural consciousness at the moment, and we're told this is the year of agents. You've mentioned knowledge graphs a couple of times, and I think this is something that we all should be talking a lot more about. And before we started the live stream, of course, you told me about some knowledge graph work you were doing at Yahoo in the early days as well. So maybe you could just briefly tell us a bit about knowledge graphs and why they're so useful.
Yeah, I mean, I built knowledge graphs both at Yahoo and Uber, actually. And in terms of when you actually talk about AI, right, like the broadest uh, concept of AI is actually a knowledge base, right? That's where artificial intelligence technically starts, right, from like a academic definition. And with the concept of knowledge graphs, you could really uh, bring in data from a bunch of different data sources, make connections that you normally wouldn't make, and even derive information based off of these existing definitions that don't exist anywhere else, right? So like the canonical example we used to use back in like the Yahoo Knowledge Graph days is that Malia is Barack Obama's daughter, and that Sasha is Malia's sister. And from that, you could, essentially derive with, certain level of confidence or probability that Sasha is also the daughter of Barack Obama, right? You didn't necessarily read that information from any source or get that information from any source,
Mm.
but you essentially were able to derive a fact, right? And basically making those connections is really helpful, when it comes to, in that case, is for supporting search, but, a variety of different AI and ML applications.
I love that you gave that example of family relations in the Obama family because it actually reminded me of something that LLMs can be completely horrible at, right? And there is the example, I can't quite remember it, but it's if you say who is Tom Cruise's mother to ChatGPT, it won't give you the correct response. But if you say who is and put her name there, it will say that's Tom Cruise's mother. So the tokens are linked in a in a very strange way, right? So we don't have the robustness of systems such as knowledge graphs, right?
Yeah, yeah. And like LLMs when it comes to giving factual information, I think like that there's well documented issues with that, right? And if you look at how they're trained and built, they're actually not really even trained for that, right? It's more of like a, probabilistic type deal in terms of predicting the next token.
Yeah, not
Uh,
to your point. So I mean, if we're building a probabilistic next token prediction system, why would we expect it to be accurate? On top of that, I think with RLHF or DPO, we've got systems which are reinforced and optimized to seem helpful as opposed to be accurate, right? So,
exactly,
uh,
exactly. They're designed to sound correct, not be correct.
exactly.
And that's something, and that's how they are now. Maybe in the future, the architecture evolves in a different way.
Yeah.
Uh, more likely, I think we'll probably see almost like a ensemble type approach where you have LLMs alongside other model types that try to correct or catch errors of whatever the LLM's outputting,
Yep.
right? And depending on the cost of compute in the future, maybe that's more viable, right?
Very much so.
Um,
You
but
could
that's
actually,
something.
I've done this. So, I do a lot of online interviews and chats like this, and then I want to get verbatim quotations from the transcript. I want ChatGPT or Claude or whatever to help me do that. It hallucinates all the time. So I've built a system which will get it to generate a bunch of interesting things. Then I use fuzzy matching and string matching to actually get those out of my documents, right? So
Yeah, exactly. And like that's something that we just need to design for and factor in, right? If
exactly.
you're trying to leverage LLMs, you basically have to factor in like it's going to be wrong a lot of the time, right? Like don't treat it like an oracle. Just
Yeah. And don't think of it, we need to change our mental model around what software is as well. It's non-deterministic. On top of that, I love that one of the first Hello Worlds for quote unquote agents is get an LLM to call a calculator and execute Python code or something like that. And pointing out that, these things aren't great calculators, which is something we would expect of software, right?
yeah, 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 for sure, for sure.
Um, So let's step back a bit, and I'd love to hear about your experiences, and I'd love to kind of frame it in thinking through what are the biggest differences in how companies like Netflix, Meta, Uber, DoorDash, Yahoo approach ML and AI infrastructure and applications.
Yeah, yeah. And I guess like looking at the most recent, few companies, Netflix, Meta, and Uber, um, they're very different culturally, at least by Bay Area standards, right? So Uber, at least at the time, was very operations driven, right? So we had a
Mm,
lot of ops folks, they ran the city teams, they did amazing work. And it was all about execution, getting something out the door, then rapidly iterating, right? Netflix culture was is pretty unique in terms of keeping teams small and specialized hiring, right? So they hire people for a specific role, right? There wasn't any generalized hiring, which a lot of Bay Area companies at least used to do. Um, that you were hired for a specific role or task, and you came in with very strong opinions about what tools you want to use and how you did things. With Meta, it's just kind of like the sheer scale is almost what makes it unique, and not just in terms of like the number of Facebook and Instagram users, but the number of people working in a particular domain, right? So, Facebook has what, over 70,000 employees, like 30,000 engineers,
Mm.
uh, and you have dozens, if not hundreds of people proposing changes to one model, right? So all of that is, of course, manifested into how they build their infra and ML infra, right? So in the and of course, like Yahoo, that was so long ago that it was like before TensorFlow and kind of all these things came into play that speaking about that experience, it will almost be like describing like floppy disks or something to
It
to
sounded
like
the way I maybe even stone tablets. No, I'm half joking there, but the story you told me before we started was so wonderful. Would you mind sharing that?
yeah, yeah. I mean, I just remember like I got my first taste of ML working on, homepage personalization and I do remember like essentially implementing linear regression offline and then like manually committing the weights into some PHP code and like computing that online to dynamically rerun components of the page. Like, that's what we did, right? Not all of Yahoo did that. That for certain use cases that was the level we're operating at. It was also all about SVMs. When we were talking about like the classifiers that went to the knowledge graph, like determining, what class this entity is supposed to belong to or this person belongs to, or what two items are duplicates. Um, I can't remember the last time somebody mentioned SVMs to me, right?
Without a doubt.
Yeah, yeah. That I guess going back to the other three, right? Like looking at Uber and Michelangelo specifically, right? So Michelangelo is Uber's ML platform, and if you look at the first few years of its existence, they took a very constrained approach, right? So all model training was actually done via UI, and you basically were able to select from three different model architecture types. So you could do a tree-based model, logistic regression, and I think it was like LSTMs, and I'm not even sure if LSTMs even worked.
Mm.
Um, and you select a few predefined features, etc., and you could maybe change 6 hyperparameters, and then you hit train, right? So very constrained that you could get things out very fast, right? And you didn't necessarily require too much expertise in ML. It was more optimized for people with domain knowledge in their own area, right? So
Fantastic.
if you knew pricing well, if you knew your city well, right, you could select the features that you think are most relevant for your particular task. And you know what? Don't worry too much about the ML side,
Mm.
we'll put up these guardrails for you. Netflix took a completely opposite approach, right? Like if you tried to pitch that at Netflix, you'd have a revolt of all the data scientists and MLEs, right?
Because
Everybody
there are
came,
too many guardrails for them, or
yeah, like you could only, select from three model types, right? And forget picking your own, type of modeling library or framework, right? Like TensorFlow or PyTorch, whatever. Uh, internally, Metaflow even supported R, right?
I
For
remember. Yeah.
this. Right? Um, so what Netflix focused on was allowing data scientists to do what they do best, right?
Mm.
So being very open to like, all right, you should be able to use whatever tool you have at your that you're most comfortable with, where you could do your best work. But you know what? We'll abstract away the infra, right?
Yep.
And we have infra engineers who can do infra, right? So that was the driving philosophy there, right? Everybody, do what you're hired to do. And then Meta, again, it's around how can you get so many people to contribute to the same goal without it being total chaos, right? So it was almost like a factory type approach.
Mm,
Uh, to be honest, I didn't really like the developer experience, right? Of like trying to modify or like propose new features to an existing model even. So things that might, you know, would have taken me like less than half a day at Uber would take 2 weeks at Meta, right?
yeah.
Because you have to go through so many checks and balances and things like that just to get something done that, there is no way it could operate in the same way that Uber operated, right? Just given the number of people working in the same domain.
That makes sense. So I'd love to now jump in and think about the role of generative AI in everything that's happening at DoorDash and other places today. So LLMs are kind of they're becoming widespread, at least in the cultural consciousness. Some in production as well, right? But they're clearly not a solution for every problem. So I'm wondering, in your work, how have you seen them fitting into into traditional machine learning systems, and how should companies approach integrating LLMs into these systems?
Yeah, I mean, great question. So, I think like we alluded to a little bit earlier, uh, you have to take into account that, LLMs aren't like an oracle, right? They are wrong a significant amount of time, right? So they have a very high error rate, not just in terms of like maybe giving the wrong responses, but maybe even the format is not even what you might expect. There's a lot of ambiguity there, right? So I guess like that's the first step really is, if you're trying to integrate LLMs into a product or surface, you need to understand the limitations of where we currently are with LLMs, right? So in some areas, it's okay, right? If the cost of an error is negligible. So you could imagine, maybe you're using LLMs to quickly add tags to restaurants or something like that, right?
Mm,
Where it's very user visible. The cost of maybe mislabeling one item, it's not a huge deal, right? Depending on like how bad you mislabel it or how
mm,
important it is.
yeah,
But if it's like the long tail items that you're missing labels for, that's okay, right?
yep,
And it's a very rapid way of getting up and running, right? As opposed to creating your own custom model that you have to train to, predict tags on, these long tail items. Uh, and even that like is going to have an error rate, right? Assuming you don't have like the ground truth that's necessary. So really just kind of being very clear about those expectations. Um, and I guess like overall, I do see LLMs and more kind of traditional models coexisting, right? You could also, view maybe some more traditional models acting as guardrails to the outputs of some LLMs, or using the output of LLMs as kind of input features to kind of like more robust models or more traditional models.
mm, without a doubt. And I love your framing of thinking through the types of mistakes they can make and how they will, like probabilistically, they will be making there will be a certain error rate, right? And I do think I actually like Andre Karpathy's take where he tweeted something like, if we're going to use the term hallucinations, we should probably acknowledge that LLMs actually hallucinate 100% of the time. And sometimes those hallucinations coincide with ground truth.
Yeah, like that's
Yeah.
actually right.
Yeah. And he compares it to search, which hallucinates 0% of the time with respect to, the ground truth in the corpus. I also love your example of low risk, where an error may not be that costly. Having said that, in that case, you still want guardrails to prevent, you know, labeling a restaurant with a cuss word, for example, right?
Yeah, yeah. Anything user visible, right?
Yep.
Really ups the risk. And even if it's not very user visible, if it's like on a very popular item, right? You don't want to exclusively rely on LLMs.
Yeah.
That it could be a great fallback, right? If you don't have anything
Absolutely.
else, call an LLM, see what it thinks, right?
Yep.
Or use it as an input. So like the LLM thinks this, let's feed it into a model with some other features, and maybe the model could give you like a better answer,
Yeah.
right?
Absolutely. Um, as part of this conversation, I'm really interested in infrastructure. And as you know, like Metaflow considers, has an opinionated, but a take that really makes sense to me on what the infrastructure stack looks like, where you have data at the bottom. You need to version things. You have an orchestration layer. You have your modeling layer. All of these things as part of the infrastructure stack, right? And I'm wondering, in your mind, well, deploying generative AI at scale often requires rethinking infrastructure in some ways. So I'm wondering what you see as the biggest changes to the stack and or significant challenges you've seen in actually productionizing LLM powered applications.
Yeah, yeah. And like this is sometimes it's very dependent on how existing companies implemented their stack, right? So some companies made the decision, or I guess some platforms made the decision that they only serve models that have been trained on their platform, right?
Yeah.
And right off the bat, you're at a massive disadvantage because you're not built to pull in kind of like a bring your own model type uh, solution, right? So one thing that I'm actually very excited about in the last few years that's changed, if you go back like five years, right, even not even that long ago, if you wanted to do anything in ML, you had to be at a large company,
Mm,
right? They had just the massive advantage in terms of not only their compute resources, but essentially the data, right? But what's changed in the last few years is that open source is actually outpacing the traditional big tech companies, right?
mm,
And I think that's a trend that's here to stay, given how, really kind of the incentive structure within all of these large companies. It's very hard to, and just really just looking at the disparity in terms of the number of people, right? It doesn't matter if how well capitalized these companies are. They have a finite number of people working there with finite bandwidth. Whereas if you look at the open source community, it's like orders of magnitude more people,
yep.
and they're just constantly trying out different things, right? So it's going to be very hard for these companies to outpace open source if they just exclusively rely on their internal tools and products and models that they've trained, right? They really need to be able to leverage the open source community. So if your stack is not able to easily pull in, the latest foundational models, or if that requires a lot of effort, that's going to be like a nightmare for you to solve, right? If your stack is implemented in a particular way. The other challenge really comes into really just like the call pattern has completely changed, right? Traditional ML, there's usually like a very standard call pattern where, the canonical example is just like, recommendations or ranking, right? So you have like a piece of content or item or store or whatever, or a list of them, and you throw that at a model that you have deployed somewhere, and then, the serving layer calls the feature store and it passes all that information along and then you get back a store, right? So it's a very transactional type deal. But when, we talk about the LLM world, like one, there's really no concept of a feature store anymore, right? There's like, RAG-based architectures and context windows and things like that, but that's not really the same thing, right? Or the same pattern. Um, and people also want to use LLMs in a more creative way than, traditional models, right? So if you have if your stack isn't built to really support that creativity or customization, that's also going to be a massive challenge for you. And I would say like that is probably going to be an area that troubles a lot of ML platforms across the industry because most of them are built around that hyper optimization. Like, how can we serve, millions of QPS? You basically had to add in some constraints, right?
Mm,
And those constraints need to be blown away.
totally. I've never actually thought about this before, and it may be a really silly idea, but I totally agree that we don't have feature stores anymore. But I wonder if there's some future of like prompt management stores and
Yeah,
data set stores for fine tuning with models, and what type of shared resources, evaluation stores, and these types of things. What type of shared resources across an organization would make sense? Because feature stores arose because everyone was building features on different teams, and guess what? Some of the features people built, other people needed. Voila, right?
yeah, and I mean it's already a need right now, right? So if you have kind of multiple people interacting with a specific model, they all have different, context windows that they care about, different prompts that they had. You want to be able to load that in and out quickly. Those are all kind of changes that need to be made
Mm,
at the ML platform level. Um, and you know, it is fairly different from, at least for feature stores, it's somewhat similar to a lot of other parts of, traditional software engineering, right? If, you had like certain key value stores, things like that.
mm.
Uh, maybe feature stores are hyper optimized for specific query patterns, and you try to group features together in specific ways, but it's not too different in terms of a query pattern, right? You want to load some data and, pass that in, whereas, loading different context windows and prompts and things like that is a little bit more custom, right?
Yeah,
Um, but
totally.
yeah.
So, how do you see the role of traditional ML models? Like, well, no longer support vector machines, thank goodness, but like tree-based methods or two-tower architectures for RecSys evolving alongside LLMs. And if you're able to speak to anything that's happening in product at DoorDash, I'd love to know. But if not, that's totally cool as well.
Yeah, I mean, like just kind of generically speaking, even before LLMs, right? Uh, a lot of the industry was on tree-based models, and then DNNs became more popular, more powerful. Uh, that people still use tree-based models, right? It really depends on the use case that you have, right? Just because you can use an LLM for something doesn't mean you should, right?
Mm.
LLMs are orders of magnitude more expensive to run and deploy compared to tree-based models.
And they
At
also
least,
seem easier to work with on the surface of things, but the complexity they actually introduce is incredibly costly, not just in terms of the cost of pinging APIs or self-hosting models, but in terms of the workflows you need to develop.
yeah, workflows, and also just like in some use cases, you need a high degree of explainability or interpretability, right? That goes away with LLMs. Um, uh, and even in some very specialized use cases, right? If it makes sense for you to like business sense, where even like a small changes in AUC or performance metrics matter. Maybe it makes sense to have like MLEs go ahead and build out like custom models using
Mm.
traditional methods, than leveraging an LLM. LLM might help you bootstrap in a particular area, but like going back to the example I used before around labeling products. um, you could start with an LLM. Maybe you fine tune the existing LLM, but maybe you actually get a great source of ground truth where you could train a more traditional model and it performs better than an LLM, right? So, and yeah, going back to again DNNs versus tree-based models, if you go to any company, you'd find that a majority of the models are actually tree-based or very simple models, right? Uh, and for a lot of use cases, that's like good enough, right? And they care more about latency than maybe like even correctness. Uh, so I definitely see continued use of both
Yeah.
um, uh, LLMs and more traditional techniques.
Awesome. To your point as well, I teach a bunch as well and teach data science, machine learning, AI stuff, and a lot of people come in and they're like, I want to learn PyTorch and rah rah rah. And I'm like, of course that's cool, but I do tell people, and I think this is something I stole from Jeremy Howard in his Fast AI course, that if you can use tree-based methods, build some deep learning architectures, and do some linear and logistic regression, that's going to get you 95% of the way for most things, right?
Yeah, yeah, absolutely.
So last time we spoke, you mentioned machine learning tools are converging in some ways to serve both advanced users and non-specialists. And I love this. I'm wondering what this looks like, what's driving this trend, and what trade-offs are there?
Yeah, I mean, in terms of like what's driving it, there's a lot of factors, like even b before LLMs, that in the current cultural moment that we're in, there's just so much interest around machine learning that everybody wants to try to use it,
Yep.
right? Even people without the same traditional background. Um, and as it becomes easier to run traditional uh, uh, I guess ML models,
Hmm.
even uh, different parts of organizations, companies, etc., parts of the stack want to leverage ML, right? So
Hmm.
even if they don't have dedicated MLE support or data science support, so how do you get started? How do you quickly bootstrap, right?
Mm.
Even like in terms of core infra use cases, right? How do you um, can you like build a model that, predicts if a node is about to go down, right? Or how long a particular job is going to take to run, right? For most companies, they're probably not going to hire an MLE just to solve that one use case, right? But it might, it might have significant impact in terms of infrastructure cost and kind of overall reliability of the system, right? So the software engineers on that team would probably want to be able to quickly bootstrap such a solution, validate whether it's viable, and then maybe later on they get more investment from, the centralized MLE org, or they're able to hire a data scientist to actually build a more robust model.
Mm.
If you're just trying to establish a baseline, um, you want like a quick and dirty way to really evaluate the use of ML in your system.
Um, so we've been talking around something, and it's the relationship between infrastructure engineers, data scientists, machine learning engineers, platform teams. And I just want to like talk explicitly about it. So essentially what we've been talking around is that ML work in like depends heavily on collaboration between a variety of different teams with a variety of different skills.
Mhm.
Funnily, one thing I really liked when last year I was in London with Savin Goyle, the CTO of Out of Bounds, who worked on Metaflow at Netflix. Amazing guy. And we went to Bloomberg's office together in London, which is one of the wildest places ever. It's incredible. But one thing I really loved is that in the office, the infrastructure team sits next to the data science team. So there's just like incidental conversations and vibe flowing back and forth that just helps collaboration so much. I'm wondering what strategies you've seen for fostering better collaboration in these types of cross-functional teams, particularly infrastructure, then people who use the tools.
Yeah, yeah. So I guess like, for platform engineers, you have to use your own product, right? So if you're building
Dog
an
food.
ML and you never trained a model before, right? Or never deployed the model before, it's going to be very hard for you to, one, empathize with your customer, and two, like understand what you're supposed to be building,
Mm,
right? So really dog food like the tools that you're building, right? From the data science perspective, my advice would be involving your eng and platform partners as early in the process as possible. Um, just to um, I guess like validate the approach and really give them a heads up around like where you're thinking and like kind of the direction that uh, you're moving in, right? So the platform team needs to be, 6 months to a year ahead of uh, the business essentially, the product teams,
mm,
right? So really being able to give that heads up is beneficial. And then they could also help guide you in terms of um, different trade-offs that you could make, right? There's a lot of different ways to build a system. And if you don't have visibility into like what's difficult and what's easy, uh, you could wind up, incurring unnecessary costs, right? So from like a, data science perspective, if you maybe model the problem in a slightly different way, then it makes it a lot easier on, the platform to support that use case, right? So really involving your partners early on and having those discussions really helps the data scientists understand the limitations of the platform, like what they can and can't do, and also helps inform the engineering and platform teams on what areas they need to increase their investment in, and what are the pain points that Emily's are
mm.
having.
Makes a lot of sense, and appreciate all your insight there. Um, as we're talking about collaboration and cultural issues, I am interested in actually a friend of mine. I don't know if you were at Netflix when he was there, Eric Colson, who he was um, VP of data science and engineering at Netflix, and then chief algorithms officer at Stitch Fix. And I'm going to link to something he wrote recently for O'Reilly Radar. But essentially, it's a piece about that a lot of people hire data scientists for skills, whereas we're probably better off hiring them for their ideas and not just have them as service centers, right? So bring them into meetings where they can listen and figure out what the challenges people are having. And I think he gives one really nice example of a data scientist in a meeting where product people and marketing people have done their like cohorted cluster analysis of users. They've had users complete surveys and clustered people, and the clusters just have nothing to do with anything that's of interest to the business, essentially, right? And a data scientist in that meeting said, well, I've got all the data now, so why don't I go and do some clustering and figure out how we can use this to move the needle on product recommendations or whatever it is. So hiring data scientists for their ideas more than treating them as a service center. So I'm wondering how you've seen this play out. So in just ensuring that ML teams are seen as strategic partners rather than just service centers.
Yeah, I mean, I've seen the industry go back and forth on this, where you have like a centralized data science org, right? And they almost act as like a consultants within the company, right? Where like, all right, we have this problem that requires like some math or something like that, and then you just like, try to borrow a data scientist for like a quarter or something
Mm,
like that, right?
yep.
And then you have like the embedded approach where technically they have the same reporting structure, so all data scientists report to the same group, but then they're embedded in specific product orgs, right? So
Mm,
like I saw this at Uber. We had you know data scientists specifically devoted for Uber Eats, and then like some cohort of that would focus on pricing. Another one would be on like personalization recommendations. Um, and then there's the third model where like, okay, they're actually just part of the team, right? And they're
yep.
distributed, and a manager could have software engineers and data scientists reporting to them, right? Um, I do see essentially like the a lot of problems with the centralized approach, just because they don't have time to build up the domain knowledge. Because a lot of it, in order to be like a successful data scientist, a lot of it is data wrangling, right?
Mm,
If you don't know where the data lives, if you don't know what data is relevant to a specific domain, even if you're like the best data scientist, you're still going to struggle to solve the problem, right?
yeah.
Because part of it's just like ramping up on the specific domain that you're in, right? Like, how do you know what metrics are even important, right? Like, if you were to go in and try to predict, I don't know, like wheat yields, for next year, right? Like,
Mm,
what would you even look at, right? But then if you ask, somebody who's like uh, has like a degree in agricultural science or whatever, that has never worked in ML before, they'll actually probably do a better job, right? Give them like the, Michelangelo UI from Uber, and they'll know what features to pick, and
mm,
they'll have a very simple model, but they would pick the right features, right? So
yep.
because they have that domain knowledge built up. And if you have that centralized org, it's really hard for them to succeed. Going through the to the other extreme, right, where you just actually have a data scientist as part of the team, that works out, but then you really need the manager to be to up level, right? So it's very hard sometimes to appreciate if if the manager has a software engineering background, they might not understand the challenges and um, that data scientists face, and might not be able to provide the growth opportunities,
Mm,
right? So if you meet in the middle where you have like that embedding based approach or embedded based approach, that works out well. Depending on the overall company culture, right? Because you do have that opportunity to grow within the org. At the same time, you do have that ability to gain that domain expertise.
totally. I I love the idea of like even software engineering leaders or managers needing to upskill and also developing a shared language. I've actually been chatting about this with a few people recently that when talking about testing in LLM or ML powered applications, right? If you're speaking with a software engineer, they think a test needs to pass 100% of the time, right? A lot of the time. Whereas we use tests in a way that if our tests are passing 100% of the time, that that doesn't smell right, right? In ML or AI. So maybe we should talk more about evaluations or teach Swees what we mean when we talk about testing as well.
Yeah, yeah. I mean, well, especially for traditional kind of software development, um, more determinism is expected, right? And that causes I guess a lot of monitoring systems, testing systems, all that are built with that in mind.
Mm,
So when you apply it to ML, it doesn't work out as well, right?
yep.
So like monitoring the performance of a deployed machine learning model,
Mm,
you know, it the traditional tools don't work as well,
yeah.
right? So you have like Prometheus for metrics tracking, which I think that spun out of Uber if I'm
I think so.
if
Yeah.
I'm not wrong.
I need to.
But yeah, like that doesn't really work for ML systems, right? So
Yeah.
you have like other products that you would use or build your own systems for it.
Exactly. Um, So we've got just a few minutes left. I am wondering, the roles of ML engineers, data scientists, software engineers are blending and moving in a variety of different ways. So, and I think everybody is kind of wondering what do I need to learn to upskill now? So I'm wondering what skills you think that will be most important for the next generation of ML practitioners and what people should be focusing on.
Yeah, yeah. I mean, it's a tricky question to answer because it really depends on what archetype you want to follow, right? So it's like a personal career decision. Some people really want to go deep in a particular area.
Mm,
Uh, if you want to do research, that's a completely different ballgame than if you want to just like join one of the FANG companies and
mm,
still like work on ML application, but in a more less researchy like capacity, right?
Yep.
Um, but if I were to give like general advice, I would say focus on gaining intuition
Mm,
um, for going too deep in any particular area, right? I know like a lot of people when they think of ML, they're like, all right, let me learn like calculus and back propagation and really go deep on the math side of things because going back to school a lot of times is like, all right, like learn the fundamentals and you build upon that. Whereas for ML, since the space is evolving so fast, it's probably better to start with like, all right, don't worry so much about the specific math concepts. Understand the intuition of like how things work and the overall architecture uh, 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 of certain systems and ideas.
mm.
And then if you want to go deep in on the research side, then like go deep on the relevant math or science that you need to learn. Um, but yeah, I would say that the focus would be on intuition rather than uh, going too deep, at least when you're first starting out.
Totally agree. On the same note, I'm interested, so well, a slightly different variation on the note for teams and individuals who are just starting to scale their machine learning infrastructure. What advice would you give them on building reliable and scalable systems?
Yeah, I mean, well, I guess like first off, that there's never been a better time to jump in than right now, just
Mm,
because of how far open source has come. To the point where like open source is outpacing big tech, even in terms of like infrastructure that's available. Like sometimes it's even easier as an individual to like, pull some like open source tools like Metaflow and then run on your own AWS account compared
mm,
to doing that internally at a large company, right? Just
yep.
because there's so much legacy software and specific checks and things that make that difficult,
Yeah.
right? So like my, main piece of advice there is use as much open source as you can. Build in a way that you can evolve because things will change. Um, and if I could plug Metaflow one more time, I would say like, maybe use that as an example, right? So separating user code from like the code related to infrastructure and the related wrappers allows you to really evolve your architecture very quickly in like a plug and play type format.
Mm,
So
amazing.
really building with uh, you're really planning for deprecation almost
Yeah.
of specific systems, right?
Super cool, man. So I'd like to just look forward for a bit. We work in machine learning, so doing some prediction isn't, too unreasonable a request. I'm wondering just where you see the biggest opportunities or challenges in ML infrastructure and applications over the next 5 years. And I appreciate that's a very broad question, but
Yeah, yeah. I mean, it's hard to answer, and I hate making predictions because I'm just like so wrong so often. Like just
that could be
looking
part of the
back
fun,
and
though.
yeah, yeah. I mean, like I remember I was one of the people that thought DL4J was gonna take off. So like that was, a miss. So like whoever's listening, like, you could maybe turn off the stream now because whatever I say is probably going to be wrong. But
But also,
uh
remember, like, it was only a few years ago that Mark Zuckerberg made a big bet on the metaverse and then generative and like I love that move, by the way, and then he's like, oh, and just forgets about, of course they're working a lot on all of that amazing stuff, but the way him and the whole team and Jan LeCun pivoted to all of this transformer stuff, like wild,
yeah,
incredible stuff.
amazing, amazing. And yeah, like, maybe after the stream we could talk about some specific stories there.
Oh,
But
I'd love
yeah,
that. Yeah.
uh, but yeah, like in terms of like the challenges for the next 5 years, it's honestly just keeping up with the changes and being able to pivot rapidly, right?
Mm,
Again, like the space is evolving so quickly. So much stuff is happening in open source, and it's not very clear what's noise and what's substance, right? So going to the second point, it's also important to stay disciplined, right? You can't chase every trend, um, but you do have to design your systems with like a added degree of flexibility of flexibility in mind,
Yep.
right? Um, and I guess like another like maybe prediction in the next like 1 or 2 years, I think the limitations of our current LLMs are finally going to set in. So there might be a period of like where we enter the trough of despair, right? In terms of
Yeah,
like
yeah.
the
The
cycle,
hype
right?
cycle.
Yeah, where people like understand that like actually, you know what, LLMs can't solve everything,
Yep.
right? They're not going to replace us all in the next 6 months. Um, that maybe that'll be like an overcorrection.
Yeah.
Uh, so I do think that will happen sometime in the next couple of years. But if I could summarize in one sentence, design for change.
Beautiful. I think that's a wonderful note to end on. I'd love just to thank you for all of your expertise and sharing it with everyone. And I'd love to thank everyone who joined live as well. It was a super fun chat for us and really appreciate you.
Yeah, yeah. Likewise, and it's great to be on here. And I guess since I am on here, quick plug for DoorDash. We are hiring specifically for ML related roles. So definitely reach out if you're interested in solving really open-ended questions in ML, designing, building, deploying ML applications, or building the infrastructure to really enable that innovation. We're definitely looking for some great folks.
Super cool. And I'm actually just at careers.doordash.com/career areas. The engineering page, I presume, is the best one to
Yep.
share. I'm
Yeah.
just going to share that in the chat now. Definitely check it out, everyone, and check out the blog. There's so much cool stuff there just to get a sense of what everyone's working on. And yeah, it's really nice how on the careers page you share a lot of what you're up to. Fantastic stuff. Well, thanks once again for us. Really appreciate your time. And Happy New Year, everyone. And looking forward to seeing you all at more fireside chats in the future. And scene.